With our simple builder pattern example in working order, it's time to take stock of its implications and appearances in the wilds of real-world development. First, as I've said before, this pattern isn't for everything. It's overkill for most classes where subclassing, refactoring, or abstracted interfaces or classes would be a better solution. However, if you find yourself looking at a class in your project that has an ever-expanding and now bloated constructor that's performing a variety of computations before setting class fields, this is a good indication that the builder pattern can be helpful. On top of that, if you have a finite number of related classes that perform the same general function but with different representations, this is also going to qualify for the builder pattern. Think of a text parsing scenario where you need to account for general functionality but accommodate different kinds of text input and output, as described in the Game of Four text. This is an excellent builder pattern scenario because there are a finite number of complex representations that need to share similar object building sequences. Now let's move on to summarizing the builder pattern's implications, because these are the real topics that I want you to come away from the course with. First, the builder pattern lets you vary a product's internal representation, meaning that the director doesn't have to know about how an object is built or its internal structure. Changing a product's internal structure is then as easy as creating a new concrete builder class. Second, the pattern isolates code for construction and representation, meaning that your code is going to be more modular and encapsulated as a result. Object creation code is written once in the concrete builders, then the director only has to choose which preset build sequence to use and reuse. Lastly, it gives you finer control over the construction process, giving the director complete control over each step of the build and its sequence. You'll only get a returned object when the director has finished calling the build sequence, which is a huge boon when you have error checking and computations involved in creating your complex object. As a last side note, if you've had experience with design patterns before this course, you probably noticed that the builder pattern shares similarities with the factory pattern. The important difference here to keep in mind is that the builder pattern is focused on object creation in sequential steps, while the factory pattern is concerned with families or groups of objects being created. In summary, we've learned where the builder pattern fits into the larger design pattern picture, how to create an object class and abstract out its constructor into an interface, how to create and configure concrete builder representations, the role of the director class in managing the overall build process, how variations of the pattern can be written to accommodate dependency injection, and the most common use cases and implications of using the pattern in real-world projects. I hope you've come away with a real grasp of the builder pattern and how it can be applied to your personal projects in the future. If you're interested in more design patterns with C#, check out our other courses in the Pluralsight library. If you've enjoyed the course, which I hope you have, please leave a rating, and if you have any questions or just want to connect, feel free to drop me a line. As always, happy coding.